urbanization, climate change, and the anthropogenic impacts. Case study on location of the sport event of the Olympic Games Rio 2016.
According to the World Meteorological Organization, WMO, there are many influences on the climate of Earth which can be distinguished into natural and anthropogenic caused by human interference. Such interference in climate has been observed by the scientific community mainly from the 20th century. Studies of various institutions such as the National Academy of Science, USA, National Oceanic and Atmospheric Administration, the Intergovernmental Panel on Climate Change, and WMO seek to clarify and monitor the causes of climate change on a global scale. These are natural or interference human. The effects of global climate change in men have been perceived mainly by the increase in temperature on the planet, known as global warming, and is thus of great interest to the human population. Knowledge of some of the major human interference in the environment that contribute to global warming are the greenhouse gases, aerosols, and change of the use and occupation of urban land. In the case of the city of Rio de Janeiro, which has the largest city of the Brazilian coast, population growth in recent decades, coupled with the vertical integration of real estate development and housing, contributes to increasing temperature capable of generating heat island in the city. It can change the direction and intensity of sea and land breezes, thus interfering in the local climate. Data from the Brazilian Institute of Geography and Statistics showed population growth up to 47% in some areas of the city of Rio de Janeiro in the period of 2000 and 2010. Thus, in the case of this study, we analyzed the impacts of human activities on the environment, especially those associated with urban change and the use and occupation of urban land, and climate. Objective. Thus, the aim of this study is to compare the temperature increase with land use and population profiles in the Rio 2016 Olympic sports sites area in order to find possible results from changes in urban land, anthropogenic impacts, and climate change over the decade of 2000. Data from the National Census of 2000 and 2010 from the National Institute of Geography and Statistics for population analysis and thematic maps, satellite images, Landsat TM in the years of 2000, 2004, 2007, 2010, and 2011 provided by the National Institute for Space Research for construction of thermal maps. There were also used studies, maps, high-resolution images, and orthophotos provided by the Municipal Environment and pictures and maps obtained from the Instituto Pereira Passos of the city of Rio de Janeiro. This material was used in the construction of maps in land use and in the delimitation of the study area. In the analysis of climate data, they used data from the National Institute of Meteorology, providing data from the city of Rio de Janeiro since 1917. To perform the analysis involved in the study, we selected the months of June, July, and August from 2000 to 2011, representing the austral winter, totaling over 10 years of collected data. The delimitation of the period is given by the correspondence of the dates of the great mega sporting events to be held in the city of Rio de Janeiro, in particular the 2016 Olympic Games. The region in the study was bounded by urban neighborhoods, which are divisions of the official city of Rio de Janeiro, and analyzed by the 2010 census, and delimited by the Brazilian Institute of Geography and Statistics for the city. An outline of the study areas was also made. A buffer was taken, having the four regions of the 2016 sporting events as its main focus. Within the boundaries of the buffer, we made more detailed analysis of the data on the map and thermal analysis of the use and occupation of land. Meteorological data were obtained from the National Institute of Meteorology, referring to the meteorological station located in geographic coordinates. We then calculated the average for each year of June, July, August 2002 to 2011, and then calculated the anomaly, observed value mean, for each quarter of June, July, August. Through this calculation, it is possible to infer if a particular variable is increasing or decreasing compared to a mean value. The mathematical formulation for calculating the anomaly is represented by the following equation. For developing of temperature maps, Landsat 5TM images and their catalog brands from the National Institute for Space Research were taken. For this work, images of the months of July and August, which represent the austral winter, and they were available on the following dates. In order to build the map of the study, the image of the brand plus 6 corresponding thermal band that had been recorded later was added. After registration, quadratic regression was applied to the following equation. The result shows the temperature in degrees Kelvin. To accomplish the transformation to degrees Celsius, they subtracted 273.15 K of the previous result. This methodology is cited by Azevedo and Souza. At the end of the mathematical process, the production of the final map, a map was constructed from the shapefile in the municipality of Rio de Janeiro, available at the Brazilian Institute of Geography and Statistics website. This process used in the study was repeated for 4 images at different dates. The study noted the anomaly of precipitation from 2002 to 2011 for the quarter of June, July, August in the city of Rio de Janeiro. In general, there is a tendency of reduction in precipitation during this period. However, the largest decrease of approximately 25 mm June, July, August is observed in the year of 2011. Obregon and Marigal analyzed the trend of June, July, August precipitation for the quarter during 1951 to 2000 and found a reduction in precipitation in the state of Rio de Janeiro. Our results corroborate those found by these authors. The June, July, August quarter, it is characterized by reduced rainfall amount when compared to other quarters. Since reduction was observed in precipitation, this implies less available moisture in the air. In turn, is detrimental to the practice of sports activities. In the temperature analysis, we found the following results. Temperature anomalies, maximum, medium, and minimum. Note that the 3 temperatures show a trend of reduction in Rio de Janeiro in the period 2002-2011. In the last 3 years, the trend is decreasing, with 2011 being the year with the greatest reduction of approximately 0.68 Celsius. June, July, August for average temperature and 0.64 degrees. June, July, August for the minimum temperature. These results were also found by Obregon and Marigon. In the case of maximum temperature, the figures shows that this variable tends not to produce more extreme values over the years. However, there is a reduction. The same was found for the average and minimum temperatures. The decrease in temperature in a region where they are always high, as in the case of Rio de Janeiro, may result in damage to human health. This favors the increase in the concentration of air pollutants and the number of hospitalizations for respiratory problems that are common in the winter. In the analysis of the temperature through the thermal maps, it was observed an increase in temperature in Rio de Janeiro within the observed period, July and August, demonstrating a greater increase in temperature in the neighborhoods of higher population density. These results corroborate studies done by the Mega Cities Project, Vulnerability and Climate Change, which states that the climate in Rio de Janeiro will be warmer by the end of the 21st century. Project report shows an increase in the higher temperatures of the year, with the largest number of hot days and nights in the year, besides the reduction of cold days and nights and increased duration of heat waves. In some regions, the minimum temperature changes can be explained by the density, which influences the change in local air circulation due to the effect of urban heat islands. The extra heat generated by the heat island in Rio de Janeiro possibly changes the direction and intensity of the sea and land breezes, which in turn may alter the patterns of moisture transport in the city. Some factors are effectual, increasing in temperature as the real estate boom, increased movement of people and vehicles, soil sealing, increased consumption of fossil fuels, and changes in land use and occupation of urban land. These variables affect the local climate, creating heat islands, generating a thermal discomfort and directly affecting people. To Amorim, heat islands favor the concentration of pollutants, directly affecting the comfort and health of individuals for problems directly related to heat, such as heat stress or disease, problems related to air quality. The author warns that this thermal stress situation occurs easily in tropical environments and is intensified with heat islands. People undergoing this situation for long periods can have problems from simple to more serious, such as irritability, decentralization, lack of appetite, dehydration, cramps, fainting, heat exhaustion, and even death. In the case of sports and sports mega events that are played by top athletes who seek maximum performance, changes in the environment can interfere with performance. In the case of the athlete, thermoregulation is very important because although the efficiency of thermoregulatory mechanisms, high ambient temperatures and humidity, along with muscle work, can lead a person from a thermal discomfort to heat stress. Depending on the intensity of physical exertion and environmental conditions, the core body temperature can rise to harmful levels to health. To Marines, the physical exercise is an environment with thermal discomfort caused by heat imposes a greater burden to the physiological adaptations that occur during the performance of physical activity. The study shows an increase in temperature and reduced rainfall, which suggests a decrease in humidity in Rio de Janeiro, the June, July, August period, which coincides with the months of the mega sports events in the city.
The study used two different techniques for interpreting climate changes by analyzing a period prior to the realization of the Rio 2016 Olympic Games. An analysis of air temperature and soil surface from satellite imagery thermal band was held in the city of Rio de Janeiro. Despite the limitations of the used techniques, results pointed climate changes occurring in the decade before the Rio 2016 Olympic Games, which is in the same period of realization of the analysis, the austral winter. Other studies by Brazilian research institutes that use different methodologies and the latest modeling techniques also found results that indicate an increase in temperature in the city of Rio de Janeiro during the century and suggest other climate change and environmental